People can join. Yeah. Now it's broadcasting. Yeah. Let's see if any other serverless circuit organizers wants to join. So we usually, like, if someone wants to join, we usually invite them. So Gunnar, we do have 1 hour difference or 2 hour difference?
Sorry?
Do we have 1 hour difference or 2 hours?
No, it's 1 hour. It's 11 here now.
Okay. Yes. It is almost time. Let's wait 1 more minute and then we can start. Okay, let's start. Hello, everyone. Welcome. Yes, as Emrah wrote, let me start by saying we use Zoom. So if you are not familiar, just under there is a Q&A part. So if you want to ask questions, you can. It would be great if you can ask there, not the chat. I mean, we are going to monitor the chat part as well, but especially as we're talking, if the question is relevant, we will try to answer them. My name is Serhat, by the way. So I work at Atlassian as a technical evangelist. So I'm interested in chaos, not as much as these guys. So I will be mostly asking questions. And before we start, I'd like to give you the stage and maybe just introduce yourselves, folks. Gunnar?
Should I start?
Yeah.
All right. Hi, everyone. My name is Gunnar Grosch. I am a cloud evangelist working at a Swedish company called Opsio. I am, since very recently, a new AWS serverless hero, which probably means that I do some stuff around serverless. I have been involved in the serverless community for quite some time, but also have a special interest in this subject, chaos engineering. So I've been working a lot with chaos engineering and specifically then chaos engineering for serverless.
And this is Emrah Shamdan. I'm working as a VP of product at Tundra.io. It's a serverless observability debugging security company, and it's also into chaos engineering, and I'm also very into chaos engineering. And I and Gunnar are actually kind of competition by being accepted for on-site talks. We are both interested in chaos engineering, and we are very close friends, and we are always talking about chaos. And I'm also very into serverless. I don't have a pillow to sleep on it yet, but like I'm also very interested in the serverless activities. Did you see like the Gunnar's pillow at the background about being a serverless hero? And today we are going to talk about like this chaos engineering thing, does it something scary, or is it something scary, or how can we do this? Okay.
Okay, then let's start. I think, yeah, it sounds scary, but before that, I think we should be answering why we need something like this. I mean, what is the problem that chaos engineering is trying to solve? Anyone wants to start?
Yeah, sure. Well, chaos engineering is about performing experiments on your environment to make sure that it works as intended, and specifically making sure that it works as intended during turbulent conditions. So that is, if there are issues, say latency, or a host goes down, what happens to your environment? So it's about verifying that things work as intended. And by doing that, you build confidence in how your application or your system works. But you also build confidence in that your organization is set up to handle those types of issues. So does your organization, your on-call, the people in the operations department, do they solve the issues that are thrown at them? So that's in short what chaos engineering is meant for.
Yeah, so when we say like verifying, for example, also it's, I mean, the definition sounds similar to testing, like, but I think we should make the difference between testing and chaos engineering clear when we say chaos engineering, because a lot of people might confuse, like, I'm already testing my code, like I'm already testing latency, whatever. What is the difference between testing and chaos engineering? It might be important in this discussion, because a lot of people might just think that, do I really need chaos engineering? Like, I'm already testing a lot of these things, right? What is the difference, I mean, in prod and maybe testing?
Yeah, well, using chaos engineering doesn't really remove the need for doing all the testing that you perhaps have today. So you still continue doing all the testing work that you previously done, but chaos engineering is more of a way of using the entire environment, using it for a lot of companies, using it in production while there are users using the system. So you add this to parts or the entire system doing these experiments. So it's a step further away from traditional testing, A/B testing, integration testing, or whatever type of testing you're doing today, and doing these types of experiments to even further know how does these added experiments, these added failures that you're doing to your environment affect the entire system.
And
so
also
it's an add-on to your testing.
And also, like, we do testing for the cases, that we know, like we are aware, like such things can happen. Like, what if I couldn't get some feedback from a third-party API, or just like, what if my code behaves in this way or the other way? But like, we do chaos engineering experiments mostly for the things that we don't know. So we are taking down some part of the system, and for example, we are just like adding some big amount of latency. And it's first, like, you may not understand how a distributed system will react against this situation. And the second, like, you don't know how your customers will be affected, both in terms of business and in terms of like technical way. It just gives you to actually break things on purpose and see what will happen in the real time.
Yep, I think as you mentioned, some things we don't know. We don't know even if they exist. And the biggest difference is, for me at least, I mean, we are going to talk about how we should perform chaos engineering, where should we start first. But I think the biggest difference is that we do this on production, and we do this with real data, with real traffic. Because, I mean, even if the environment is the same as staging, production and staging are the same, but they are not actually the same, because the traffic, the amount of traffic we are receiving is different, and that makes all the difference. Production will always be different when we have, we are going to have different new unknown incidents all the time, right?
Yeah, and but this is also one of the perhaps problems with adopting chaos engineering, that we're constantly hearing that you should do these experiments in production, and that is a problem for a lot of companies, because they don't really have confidence in their system. They don't know what will happen if there is a failure added. So injecting failures into a production environment, that's probably going to hurt. And when we do our experiments, if we know that something's going to fail, we abort before we actually do the experiment. So moving to production, that's probably more of an end goal. I shouldn't say that's the way to start doing chaos experiments. So we can still create our experiments, we can perform them in our test environment, staging environments, or playgrounds, whatever we have. Because that's a way for us to start developing the actual experiments as well. We need to create them in a way that we know how they work and so on. So starting out in something else than production, that's totally okay. But we want to move to production, because that's, as you said, that's where we have the real traffic, we have users and so on. So, but not everyone is Netflix. Netflix, when they created chaos engineering, they have a lot in place. They have processes, they have systems, they have ways of building things that is far off from most companies. And that's something, I guess you hear that quite a lot as well, Emrah, that we are not Netflix, and that's fine. It's totally fine to not be Netflix. You can still do chaos engineering. You don't have to go all the way and have it automated and have things being destroyed in your production environment through automation. It's fine.
Exactly. So like chaos engineering is not a cool game just like to attack your system just by planting a bomb inside of it. Instead of like, we need to remember that the first state of a chaos engineering experiment is actually defining a steady state of your system. So you should first, like even before injecting the first failure, you should be very confident about like what are the limits of your system, what might be like the normal behavior of your system. And even after you understand that, you don't need to just attack the production with your first chaos experiment. You can just do the same in staging and just like understand the behavioral mechanics of chaos and experiments and understand the ups and downs of your system before actually you are doing it like Netflix. And I don't know like many companies who is actually doing chaos experiments on production at Netflix. Like there are some companies that we know, but it's not actually like hundreds. It's not even like tens of companies that we can think of. Like everyone is just like starting chaos experiments, not necessarily on production, right?
Exactly. When I first heard about chaos engineering, that was the first thing on my mind. Like, wouldn't it be hard just to do this on production? And then I thought like we should have proper monitoring, logging, alerting, incident management process in place. Then just wait for a lot of these things, and you're not gonna do anything about chaos engineering. And I think so. Have you heard about this pledge one thing? Like you give your companies 1% back to like charities every year, right? So I think the idea is similar. So the not the idea, but so what they recommend is you start doing this thing when you are small, when your company is small, so it doesn't look like a lot. Like because when you are big, just giving 1% is a lot of money, right? But when you're small, when you start something like this, when you're small, it is not that big of a deal. So then when I think about like chaos engineering in a similar manner, like if you are not that big, you don't have a lot of traffic, you are just starting, you have some traffic, but not a lot, then injecting these kind of problems even into prod, it's not going to hurt that much, even if you don't have a lot of just best practices in place. So, I mean, I don't know if this is a right like way of thinking, but because we don't want to wait for like maturing our processes, maturing our tools, maybe even if you don't have a lot of the things in place, especially when you're starting after some, maybe you have some customers, but you're not still that big. If you start chaos engineering, it will be easier, maybe.
Yeah, well, I agree that if you're constantly waiting for other processes, other things to come in place before you start doing chaos engineering, then you'll probably never start using it. So to start when you're perhaps not the smallest company, but when you've started to grow a product, I think that's a great place to get started. And sure, you need to have some sort of basic reliability, robustness in your system to start using it, because otherwise you know that things are going to fail. If you're using EC2 instances, you need to have them, well, perhaps in multiple availability zones and multiple instances and so on. So you're able to actually do an experiment that the system will be able to handle. But yeah, I think you're able to start early on, and I think that makes it easier for the organization to adopt the way of doing those types of experiments as well. And one thing to remember here, I think, is that chaos engineering, it's a really cool name. I think we have to admit that. And the thing about it is that chaos isn't actually what we are doing to the system. It's what is inside the system already. When we're building distributed systems, they have inherent chaos, that things can break in ways that we can't even think about. And by doing these experiments on the system, we're drawing out the chaos. We're finding where the chaos in the system is. But adopting chaos engineering, well, if it had a different name, this is an old debate, but if it had a different name, perhaps would be easier for some organizations. That's why some are starting to talk more and more about verification rather than chaos experiments.
Mm-hmm.
And I think that might be smart if you're taking it to management, saying that you want to cause failures in your system. Well, you're probably not going to get a go ahead, but if you say that you want to verify that your system works as intended, well, that's probably easier.
Yeah. Yep. So, like, Serhat, would you like to take?
Yeah, go ahead.
Like maybe Parag is asking about just a small brief. Like it all started with like distributed systems. Like Netflix in 2010, they had a damn distributed system, and they still have. And they wanted to understand what if, like they wanted to ask these questions. What if like my database becomes unreachable? What if my third-party API, if I'm using, what if the internet connection of the customer is just closed down? It's just asking these questions. And the best way to actually answer these questions is actually to do the same to your production and see what will happen, and just take precautions. It's just actually defines the kind of steps of chaos engineering experiments. And it all starts with defining your steady state. So how is your system is behaving normally? As Gunnar says, there is chaos already in the system, but you just need to have a sufficient amount of knowledge about this chaos and understand the steady state before you put an hypothesis. Just like you are just putting an hypothesis that like, hey, this is how my system is like behaving like normally. And I believe, as the software developer, tester, CTO, whatever you are, if I inject that failure, if I, let's say, take down all the region, my system will continue working with a, small delay, with like that much of delay, or with some problems. It can also be with my theory, and you are just like wanted to actually test this theory on production. And as I said before, it doesn't necessarily be on production for the first time. And after that, you see something to be fixed, you fix it before like it really happens in production, or you don't see anything and you just redo another chaos experiment. And after that, but like this is kind of a bigger picture, like a whole pipeline of a chaos. But defining steady state of your system might be a subject of a 2 hours talk maybe. So, so like, how should we define the steady state, Gunnar? Like, what do you think about it?
Well, steady state is really important, and not just for this. I think the steady state of a system is something you should know even if you're not doing chaos experiments. And the steady state, it usually consists of the normal technical metrics that we usually have in a system. It might be CPU levels, amount of memory disk, number of hosts in an auto-scaling group, and so on. But more important is usually the business metrics. Because business metrics, well, that's usually where we make money. And once again, taking Netflix as an example, their most important business metrics is the stream per second, I think they call it. How many streams are started each second around the world. And if that dips, it means that usually there is an issue of some sort. So they want to keep that steady. And that's usually how they see if there is an issue in the system. So when they build their chaos experiments, they do it around the SPS. So that's also the way that they monitor their experiments later on as well. So when they're running the experiments, they look at those metrics to see what effect does it have. So I see we got a question as well about end users, if they are being affected, and they might be. It all depends on how your system is built. Looking at the Netflix example once again, they do their experiments on with a set blast radius, and blast radius is something that we define. How big of an impact should this experiment be able to have? And the blast radius might be X% of users, one country, people watching this specific title if it's Netflix, and so on. So they do an experiment that has a defined blast radius, and that's how we always do our experiments. So we don't go full out and make an experiment straight away that might cause the entire application or system to go down. We want to affect a small part, the smallest possible part to begin with. And if the experiment is successful, then we're able to scale up the blast radius, perhaps affect more users or add additional countries or whatever the blast radius was set to from the beginning.
So can we say, like, if we want to do this on production, we should have the mechanisms to do A and B testing, kind of like we should be able to try this on just, let's say, 1% of the traffic.
Yeah, definitely. It makes it a lot easier as well to be able to abort the experiment. One big part of creating an experiment is to know exactly how to abort it. So you're able to go back to how it was before you either get a cascading failure of some sort, or before you actually lose revenue if you're doing it in production. And by setting it to, as you said, specific users or so on, then you should probably easier be able to go back as well.
And the good part is, because we don't know what's going to happen, but the best part of chaos engineering, I think, is one of the best parts is because we know that we are doing this experiment, everyone is already awake. Like, we are not getting this at 3 a.m. in the morning, right? We are not waking anyone up. Like, the team maybe is everyone is in the same place, so they are ready to respond. That's one of the advantages.
Yeah, definitely. Chaos experiment is really a team effort, even though you perhaps have one or a few people who are actually managing the chaos engineering in your company. You involve as many people as needed. So you shouldn't keep it a secret that you're doing an experiment. You don't want people to find out that you took down parts of the system and it was planned. You want to involve people so that they know what's going on. It's important because it helps people to prepare as well, to perhaps think a few times extra about what should we do in these types of well, if we have these types of incidents.
It's mostly called game days, like everyone in the company actually knows about it. Like, this is a game day in which we will just test an hypothesis. And our hypothesis is that we will keep the blast radius. We will just take down 2 servers, but while we have 2000, and see what will happen. And our hypothesis is that nothing will happen. The traffic will be handled by other servers. And we should also have in this game day that kind of like a backup plan, like how we will actually just like do some kind of a roll-up plan, and we will change everything to normal before it actually impacts the most of the customers. It goes like, if it fails, we need to know how we will actually react to this one. So it should be planned before in advance, like, hey, we will run the game day, we will test this. If we cause a bigger problem, we will just roll back it in this way. If we don't cause any problem, okay, fine. We will just like conclude it. But like, everyone should be aware of this plan. Everyone should be actually getting involved. And the best chaos is like is not about like surprising people about, hey, we didn't, your part is actually down now, do this, like whatever you can. It's not the kind of a chaos experiment that we can think of. It's kind of actually a little bit joke to your colleague. And you know, I was about to also ask about like who should be involved in this chaos experiments, like which roles, like CTO, like developers, testers, maybe even some customers. Should we ask customers that, hey, we will do an experiment?
Well, yeah, I'd say that it of course depends on what type of system you're running, but when you're starting out doing chaos experiments, you should involve as many people as possible. Of course, everyone that can be affected. So if you're doing using a system that has customers that might be affected and might call support or whatever, then of course you need to involve your help desk as well, so that they are aware of what's going on. But usually it consists of the different types of operation roles you have, probably developer roles as well. So technical engineering roles, but usually some sort of management role as well, of course, handling the teams. If you are a smaller company, you usually, or you probably don't have a chaos engineering team. It will be people that are doing other stuff on a day-to-day basis that also work with chaos engineering as a part of their role. So it might be people in DevOps, for example, is quite common, or SRE, site reliability engineers. I guess those are the most common roles that also do chaos engineering.
Mm-hmm.
You mentioned game days. I just want to say that game days is a really great way to do this and to practice it. And even though we usually talk about chaos engineering, which was created at Netflix, there are different very similar ways of doing these types of experiments with different names, but chaos engineering is the one that has stuck, perhaps because it's a cool name. But Game Days was created at Amazon by Jesse Robbins, and they did this actually before chaos engineering was created at Netflix. And Google has their own way of doing this. I think it's called DIRT. Microsoft does some sort of chaos engineering as well. So there are different branches, but all with more or less similar goals.
I didn't know about Microsoft, like the name.
The Google name, DIRT.
Yeah.
Yeah, it's an. I guess it's short for something, but I can't remember it.
So I have a question. Like, we talked about setting up your hypothesis and just communicating the stakeholders, having a rollback plan in place. But we talk about these things like separately, right? So are there any guidelines or any even resources that you recommend? Maybe we should ask this at the end, but I think it's in place, right? We talked about this just recently. So maybe I'm a little bit confused, like how do I start it, let's say? Is there any, I don't want to say it's, probably it will be different for different companies, but are there any still structured way of doing chaos experiments?
Well, yes, there is. the team at Netflix, they created something they called the principles of chaos, which I would say is the baseline for everything we're doing around chaos engineering. So there is a website for that, principleofchaos.org. They also created or wrote a book around chaos engineering, the book on chaos engineering. So that's available at a lot of bookstores, so you can get that. But then there is also newer books out there as well. Russ Miles has written a great book on chaos engineering that was released last year, if I remember right. So there are a lot of written things around chaos engineering, but there's also a great deal of content available. An awesome collection in GitHub that has a lot of links to different resources. I guess we can put up these links later on, Serhat. Then there are tools, of course, tools that you can use for chaos experiments. One of the perhaps most talked about tools at the moment is Gremlin, company that has a SaaS product for chaos experiments. So you're able to do chaos experiments using their tools on your environment. And they also have a lot of resources in written form, documentation on how to do experiments and so on.
So it's like Chaos Monkey, but managed way, like it's a SaaS product.
Yeah.
Right. Similar to, if you know about Chaos Monkey, it's similar, but it's a managed service.
Yes, correct. So it's an agent you can install and then use that. So then we also have an open source tool called the Chaos Toolkit, which is another way to do more or less the same thing without it being a SaaS tool that way. And there are more and more tools being released, actually. So a lot of stuff is happening in this field at the moment.
And I just wanted to add the Casey Rosenthal's book. It just came out like maybe a month ago or 2 months ago. It's also seems like a very nice one, but I couldn't check it. Let me find it while we are talking. And also, like, there is a question about like what are the common failures. So like what will be the failures that we need to test? Would you like to take this one? No, while I was taking for.
Well, yeah, sure. Well, it of course depends on the system you're running, but if we're talking about traditional infrastructure using virtual machines, containers, and so on, most tools today have ways of testing things that might happen. For example, if you have high CPU, if you have latency, if you have networking issues, if one or two or multiple hosts goes down, if containers are failing, and so on. So you're able to do experiments in those ways by injecting those failures into your environment. For example, we talked about creating an hypothesis, that's one of the things that we're doing. And hypothesis is a really scientific way of defining your experiment. What if my database goes down might be a question that we're asking. What will happen to our system if the database goes down? And by asking that question, we're able to define that hypothesis, that I believe that if the database goes down, my system will go to the fallback database, or my system will fail over to some other state. And that's the hypothesis that we're then going to perform our test upon. So the test in that case will probably be to take down the database, because I have said in my hypothesis that the system will be able to cope with that problem. Then we perform the experiment and see, did my system go to the fallback? Did we fail over to the secondary database, or whatever the hypothesis was? So finding what common failures we have in our environment, it really depends on the system, but many, of course, are based around the traditional infrastructure that we're using. If we build something with autoscaling, what happens if autoscaling fails? Or what happens if if we have latency between regions, for example, if it's a big distributed system. So we need to use our imagination and find things that might fail and build experiments around those. And successful experiments doesn't mean that nothing fails. A successful experiment for me is that you do something and you learn something. You do an experiment and you learn something new, because learning is actually the key here. You learn that, well, we did this happened. We also noticed that the system coped in it in a way that we haven't thought about. We didn't build it to solve the issue this way, but it actually did. So we learn new things about the experiment, not only while doing the experiment, but probably learn new things while creating the experiment as well, because you put together a team of persons creating an experiment that they probably don't work together on a day-to-day basis otherwise, because they are a part of different teams. So smart people together in a room will probably learn new stuff.
Definitely.
Long answer for a short question, but
that's great. That's good. Anything to add to the common failure part, Emre?
So it actually depends on your system. Like you know, like the most common failure, I would say, like, what if this machine stops working? But like, what if you don't have a machine? Like, it's actually for serverless, like the common failures are actually changing. For serverless, it becomes like, what if my function times out? While calling it downstream service? Like, and what if my like function just like retries forever, and I'm just in the middle of a retry storm triggered by Kinesis? So it just like change, like it. The common failures can also depend on the what's your system is about, like, and that's why I just wanted to bring the topic on serverless now, and I just wanted to ask, like, what might be like, why chaos engineering is important in serverless.
Emre, before that, I want to add one thing. So when I tried Gremlin like one year ago, or maybe two even, so tools like Gremlin or open source alternatives, they all have built-in common scenarios. And if you are using, let's say, EC2 on Amazon VM, for example, one of the common ones are like, if there is there's something going on with any virtual machine, if it cannot receive any traffic, so you can simulate that, or if your load balancer is returning some sort of like, if it's down, if your domain name cannot be reached, these kind of like, there are built-in scenarios. I think most of the like load balancer or domain kind of failures are common for many applications. So that might be one of the answers. Yeah. Then
it's always DNS. Yeah.
Yeah.
No, but that's right. That's definitely
the serverless part.
And just yesterday, or I guess tonight, Gremlin released a preview for Windows servers as well. So an agent for Windows servers. So if you're running that, you can start trying Gremlin now as well. I don't work for them, but.
Yeah, so the serverless part is interesting. So when first, obviously, Netflix started all this, it was mostly about EC2 machines, and then we had containers, we had Lambda, serverless tooling. A lot of people are now using those tools as well, even Kubernetes. So can we apply the same principles? What is different in, for example, it's an interesting question to me. What is different in experimenting with EC2 machines versus Lambda? Like, what is different, and how do we do experiments on a tool like AWS Lambda?
Yeah. Well, I would say that there's two parts of it. We first have our functions, be it Lambda or Cloud Functions or Azure Functions. And then we have all the fully managed services that are more or less known as serverless services. And a lot of the pros that we have with serverless, that we don't have any servers to manage, we don't have to manage infrastructure and so on. That's also one of the issues with going serverless, that we don't know what's happening underneath. We perhaps don't need to know as well, but it means that we have even more unknown failure modes. We have failure modes that we can't really control. And a problem with using chaos engineering on serverless is that we don't have access to the underlying infrastructure. So we can't really create the same types of experiments because we can't shut down EC2 instances, or we can't destroy containers. But we can still do chaos experiments. I would say that a distributed, which is more or less what every serverless system is, a distributed serverless system has even more inherent chaos, because there are so many things that can go wrong. For each function, for each managed service, you have security settings, you have configuration settings, everything is separate. When you run things on your own instances, you perhaps don't have those types of configuration options for each and every function within your service or your application. So there are more ways that things can go wrong. And also one of the things that, or a promise with serverless, is that it has automated scaling. It will handle any load. It will just work. But as we know, everything fails. So everything will fail sooner or later. And using chaos engineering on serverless gives us a chance to actually test what will happen with our application if something fails. And as Emrah said before, it might be added latency, or it might be service failures, a downstream or upstream service that doesn't respond at all, doesn't respond in the correct fashion, and so on. So we can create experiments to simulate those issues. We can't really do them exactly every time, because we can't remove DynamoDB from the equation totally, because DynamoDB will probably always be there. But we can simulate that DynamoDB is gone, or we can add latency to our functions. So I'd say that chaos engineering fills pretty much the same role for a serverless, and it's probably easier to get started with as well.
That's great. So we do have some questions, but before that, would you like to do the demo?
Well, yeah, sure. Definitely.
Emrah, in the meantime, do you want to add something?
While he's preparing, I can also add, like, we also like started to do, like, discuss chaos engineering. It just like roots from like distributed systems, and serverless is distributed, like so damn distributed, like by its nature. You just start with, like, it's and then Lambda function gets triggered by API gateway, just like writes this request to Dynamo. This might be like your like a small use case. Then it evolves like a Pokemon. Like I always have this on my slides. Like you start with like Charmander, but then it just like became so like event-driven asynchronous architectures, and then you even yourself don't know what's happening in your system, because like you write something to SQS triggers something Lambda function. Lambda function gets triggered by Kinesis, God knows how many times when it fails. And just like there's already a chaos inside, and you need to understand how the system is working. And chaos engineering experience in serverless actually increases your knowledge, not only confidence, about your system. You just become more aware of what you are doing.
So let's see if I can start screen sharing. Too many screens. Screen 2. Okay. Are you able to see anything?
Yep.
And what are you seeing?
We are seeing your demo site.
Demo site.
Cool. So to get started using chaos engineering for serverless, there are a few options at the moment. Either you can use Gremlin has their part of Gremlin that's called Alfie, which is a tool for application layer fault injection. It's a bit limited at the moment, but I think they're building it out. Also, Tundra, as Emrah knows well, has a way of doing chaos experiments through their platform. And there are also other open source tools. Adrian Hornsby, evangelist at AWS, has created a library, a Python library. And then also I've created a library for Node.js. So you can start doing some chaos experiments using Node.js applications. So I created this simple site just to help show how it might work. And it's really simple. It's a static web page that calls 3 different Lambda functions. Each Lambda function in turn gets data from a DynamoDB table and then returns an image. So the image is shown. It refreshes every, I think, 5 seconds. And this Lambda or this NPM package, it's more or less a wrapper that you use for your Lambda function. So you wrap your entire handler with this package, the failure Lambda package, and then you're able to inject failure into it. Let me just show you. Let's open parameter store. So the failure Lambda package, it uses parameter store for configuration. So you're able to enable and disable these chaos experiments using parameter store. So if we just open the first one, as we can see here, it says that this is the code we're looking at. Just get a bit bigger. So it's just a piece of JSON that at the moment says that it's not enabled, it's false. We have different failure modes in the package. At the moment, it's set to latency. And what that means is that each time we do an invocation of this Lambda, it will add latency as soon as I change this to true. And it will add latency at a minimum 100 milliseconds and maximum 400 milliseconds, something in between that. We also are able to set the rate. Rate means that if it's set to 1, it will add the failure on each invocation. If we set it to 0.5, it will add it to roughly 50% of the invocations. We then have a few different other failure modes, but let's just try this one first. So looking at the demo site, function 1, each time it is invoked at the moment, it's just below 200 milliseconds or just above. So if we change this to true, it should start adding latency somewhere between 100 and 400 milliseconds. So let's change that. Yes, and as we can see now, on each invocation, it was around 200 before. Now it's just below 400, just below 500, and so on. So now we've added latency to this function. And by doing that, we're able to simulate latency in Lambda. It can either be latency on the platform itself, because to be honest, it might happen that there are issues with Lambda that adds latency. Or we can simulate stuff using it. We can simulate cold starts. We can simulate latency through issues with our code or through dependencies and so on. So that's one example. Let's just try the second one. And in this case, I've set the failure mode to status code. And status code means that we're able to manipulate the status code that is returned by our Lambda. On a normal invocation, it will return a 200. But in this case, I've set the status code to a 404, which means that on each invocation, it will return a 404 instead. So let's enable this one. True, and let's change the rate as well. Oops, set it to 0.5 and save. So that means on each invocation now, on roughly half of the invocations, it would add a 404 instead of a 200. So let's see what that means. Yeah, so now we have a 200. Next invocation is a 200. Let's see again, 200. I said roughly 50%. Okay, status 0. It doesn't say 404, but it's still an error. Now we have a 200 again. So by doing this, we're able to simulate that there are issues returning different error codes. We use the 404 right now, but it might be a 502 or whatever error code we want to test. So that's a way to create issues to see how does our application handle that. And usually in an application, if we have issues of this sort, we should probably use some sort of error handling in the application to make sure that the users don't see an error message. They should probably have a fallback of some sort instead. And let's just check out the third one as well. And this one uses the failure mode that's called blacklist. And blacklist means that we're able to blacklist invocations to perhaps third parties or down or upstream services. In this case, I've blacklisted S3 and DynamoDB. So if I change this to true, since the function, as I said, it's calling DynamoDB to fetch the image. When I set this to true, it should, if all goes well, not be able to call DynamoDB and therefore not be able to get that result. Still working. Still working. Okay, still working. That's good.
That's nice.
Did I change the right one?
It's the chaos in the demo.
I did. Yeah, but that's usually the case.
Yeah.
That's strange. Okay. Well, it usually works. So these are just some examples. There are some more failure modes as well in this library. And as I said, Adrian Hornsby has created one for Python as well that you're able to use. It doesn't work in the exact same way, but more or less. So you're able to wrap your functions or your specific calls with those errors. Yeah, so that was a short demo, but it just shows that it's possible to do these types of experiments, and it's fairly easy to get started by just installing a package and wrapping your handler or your specific parts of your function to start doing it.
It was great. Thank you. I mean,
just for advertisement purpose, like just for a sentence. So Tundra already has a wrapper to monitor your functions. So with Tundra, what you need to do in terms of like injecting chaos is just adding some environment variables or just adding them programmatically. Since we already have a wrapper at the place to monitor it, we can actually inject some chaos, like, and it's becoming like more automated. And we are supporting for Node.js, Python, Java, .NET.
Yeah, and I think that's really smart that you have it integrated in the platform that is actually getting you the metrics and the observability to the platform. Yeah. So it makes it easy to see exactly what is happening as well. I don't think I'll extend my failure Lambda package to include observability, so not competition.
Yeah, please.
We do have about 10 minutes. Let's go over the questions. So there are two questions related to your demo, I guess. What is the Python library's name? I don't know.
I should know that by heart, but I think it's is it failure lambda, but with an underscore? I can easily check that.
The other one is, does the parameters you have shown us replace the event parameter in Lambda?
The event parameter. I'm not sure if I get the question correctly.
Yeah, let's skip that one.
Yeah.
So there was a question that Emre answered. So I do have a question related to that. So the question said, like, if the big cloud providers are doing experiments in chaos experiments for their services, and there is a great blog post from Adrian, so we can share that on the main chat room as well. Maybe Emre, I don't know if you already did, but so about that, I do have a question. Like, we see these third-party tools, right? What do you think about, for example, AWS bringing some sort of easy way to make these experiments, just built-in service, whatever? Like, I think it makes sense.
It does, and let me say that that's a topic up for discussion. I'm definitely for that, to make it easier to do those types of experiments, since what we're actually doing is we're simulating errors, since we don't have access to the underlying infrastructure. But sure, some of the errors, when we're adding latency, it means that we're adding latency. When we're blacklisting something, it means that we're blocking it on a network level. But having that possibility to do those experiments in a controlled way through the platform itself, yeah, I think that would be really beneficial. Definitely. But as they always say, they can't comment on future releases. So.
Of course. So what is it? So there was a question. Let's go over one by one. Which steps should be better for chaos engineering testing steps when we design an CI/CD pipeline, or should we plan separated from the pipeline?
That's a good question. Some companies, or at least companies that are mature in the chaos engineering space, they have this implemented in both their CI/CD pipelines and through automation in different ways. And I think it is really good to get there, but I don't think that's where you perhaps should start. To have it separate is usually the place to get started with it, but having it in the pipelines means that you're able to do it over and over again on each deployment, for example. Having it separate probably means that, sure, you perhaps can call it through the pipeline, but you usually do it manually. But manually is probably the way to get started.
Yeah, great answer as well. So the other one, we do have two more questions. Our company is moving to event-driven architecture and using serverless with the approach, and due to scale and concurrency issues we are facing, service failures issues in Azure Function apps. Will this count as chaos experiment, though a failed one?
I'm sorry.
Maybe chaos for Azure, not for you.
Yeah, well, I don't really have a good political correct answer to that. But I can say on that topic that the failure lambda that I showed just now, it's actually available for Azure and Google Cloud as well. So it's a Google Cloud, failure Google Cloud, and failure Google functions and failure Azure functions. So if you're using anything else but Lambda, you can still use the same type of library to do those experiments, if you want to do it in a more controlled fashion.
That was a question I typed like with a kind of a humor. Like someone asked about like if like the AWS already guarantees that like their service will be up for like, let's say 9999. And do we need to run chaos experiments on that? And I just replied with like Werner Vogel's quote about like everything is failing, everything fails all the time. So you should do on those as well. Like we don't expect.
And SLAs are mainly financial numbers. So sure, if they breach the SLA, it means that you might get money back. And looking at an SLA for example, Lambda, no matter how many 9s there are, it also means that there will be, because you have so many invocations usually of Lambda, so it means that you will have things that might fail. 1 million invocations, that's not that many. So if one of those fails, what does that mean to your application? So even though the SLAs are high, it's mainly financial. You should still do experiments to see how things work when they fail, because they will fail.
Yep. And one more question. So I can also add, like, the question is how much chaos engineering is related to adaptive runtime requirement engineering. Maybe I can also say how much is it related to resilience engineering. So I don't really have a good answer, but maybe. Well,
it is related, but chaos engineering is perhaps more of a practice. It's principles for doing a specific type of practice. Resilience engineering is a broader field, and it's also an older field, something that didn't start out in tech. It started out in aerospace. It started out in fields where they really need to have resilient systems, power systems, and so on. But it's something that has been adopted in IT and is a growing field here as well. So if you work with resilience engineering, you might use chaos engineering as well. Let's say that's how it's related.
Okay, I guess we are out of time. Anything you want to add before we close?
Well, I would just like to add that feel free to reach out if there's anything you want to talk about in regards to chaos engineering, serverless. I'm on Twitter at Gunnar Grosch. Feel free to add me on LinkedIn as well. I'm always up for talking about these things.
Same is valid for me. Find me on Twitter or LinkedIn.
Same for me. And also you can we don't really, because we don't have a lot of followers right now on our YouTube account, we don't really have a fixed name, but you can just search for Cloud and Serverless Turkey on YouTube, or we send the link, and you can reach out to these and the other events videos on YouTube. Most of our events are in Turkish, but this one is in English.
I'm happy for that.
Yeah, exactly. Great to having you, Gunnar. So then let's call
Thanks everyone for joining.
Thank you all.
Thank you.
Thank you.
Bye-bye.
Bye-bye.